Hey everybody, this is Larry. This is me going with Q2 of the bi-weekly contest 141, construct the minimum bitwise array 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one, I honestly, in my head, I misread this a little bit, which is why it took so long, and because I just couldn't figure it out. How I actually did it, you could watch the live portion of it. How I did it is that I took the Q1 problem, and then I did a for loop to print out everything and then try to figure out a pattern. And I did figure out the pattern, which ended up taking 7 minutes. But it's probably not the way that well, look, at the end of the day on a contest, you do what you have to do. You do what you have to do within yourself, right? Not trying to say that you should cheat or use ChatGPT or whatever. I don't know. But yeah. The idea here is that, and the way that I did it, like I said, I just kind of did it by observation. I just observed that all the answers are going to be n minus, or let's just call this x minus 1 power of 2. And honestly, during the contest, I didn't look further than that because I got the right answer. And 2 is the only negative 1. Yeah, that's just the way it is. The key thing to know for this problem is that when you have you have to start thinking about what this formula that they give you is, right, for bitwise OR. You can think about it as bitwise manipulation, but I would just play around with some numbers, right? For example, if you have, 7 and 8, right? 7 or 8, because of this +1 thing. This is the only time where, well, in this case, then, going from 7 to 8, you actually get a number 15, right? Because it almost is multiplying by 2. However, if you play around with smaller numbers, like, I'm just banging on the keyboard a little bit, like this, and you add it by 1, then what does this mean, right? Well, this means that when you do a bitwise OR the prefix doesn't change, right? Because you're adding 1, that means that you only do the carry to the next bit. Alright, so you're kind of shifting. Another way of thinking about it is that you kind of, you're just adding 1. So there's only one place to carry, and the prefix doesn't change. And if the prefix doesn't change, then this is the number that you need. And this is the way that you can kind of see why it has to be a power of 2, right? Because if you add, because then now, this number plus this number is going to be a power of 2, but if you have, well, it's just, right, because this number plus this number, this number and the bitwise OR of this other number is just going to be and this number minus this number is always going to be just a power of 2. In this case, it's 10 and 2, which is going to be 2, right? But if you kind of write it out, like I said, the prefix kind of cancels out, really. But you can also think about it in terms of, that's if we add 1, right? Another thing is that if you have a lot of 1s at the end, like maybe something like this, then now if you add a 1 here, it actually, zeroes it out, right? And then now you can see that because these zeros don't matter because it's a bitwise OR, so we can just say that this adds actually the next 8. So then now, so this is how you get from, this is the observation between an x and for number x, bitwise OR x plus 1. So this will give you, this operation gives you some power of 2, right? So this means that I sub I, so this function plus some power of 2 is you go to num sub I, right? And that's pretty much it. And basically what you can think about that is that you just brute force on this number, and that's really the idea behind it. And that's what I have. I think you probably could do a little bit better if you are wanting to. But yeah, but I think that this is the general idea, and I did it with bitwise operations shifting, but you don't have to. let me write something like P is equal to, let me clean this up a little bit because this was contest code. So you can say that, you have this, right? So this will work, obviously, because I didn't really change anything yet, unless I changed it incorrectly. Okay, right? And then here you can also just convert this to like, 2 to the power of I, and it should also work, right? So that's the only thing, right? So yeah, and this is the calculation for one function, one number, and you just do it for all the number, keeping in mind that x. But yeah, that's all I have for this one. Let me know what you think. So this is the complexity. This is going to be linear times the number of bits, right? This number takes O of 32, which is number of bits that we have in the input, and this is O of n, so this is n times b, if you will. And yeah, that's all I have with this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest. With what you see how I figure out the pattern, but honestly, looking back, or like thinking about it back, I probably should have examined the property a little bit more. I don't know. I think today I woke up a little bit, my brain is a little bit of a fog, and I just, yeah, and it showed. But yeah, you definitely check that out. Thanks for watching. Okay, and now Q2 is the same except it's 10 to the 9, so I can't do it that way, right? Well, let's keep it open so I could run this code on it. Let's see. There's only 100 numbers. Oh, and nums of I is prime. I actually didn't even take advantage of that. The claim is a 5-pointer. It's a prime. What does it mean that it is a prime number? Three is 1, 5 is 4, 7 is 3. Why is 7 3? What is the binary numbers? No one's counted yet, supposedly. Only 100 numbers though. Prime, what does prime mean? Actually, I guess we could use this to kind of look it up. This may be not too much, but we'll see. One, actually, I forgot that. Well, one isn't prime, so it's fine. Wait, is that? Yeah. Okay, so not all these numbers are prime. What happened to they are prime? Don't even know how to write a CIF. Look up a piece of I. Nope. What are you doing? Technically this, but Oh. Oh, 2 is just -1. I guess that's why. If I is not in. I stopped writing it this way. It's kind of weird. So only -1 is 2, right? It seems like it, because everything else. Okay, so okay, yeah, and it's either no. It's like per bit almost. 63 times 64. That's it's powers of 2 minus 1 is this one. These ones, so 8. But this is also weird. Did you get this one yet? Well, a lot of people got it already, so I'm just doing it. Maybe I'm doing it funkily. Oh, I see. The answers are always powers of 2 difference, right? That is a funky thing. I don't know how to prove it, but okay, fine. Otherwise, then we just check x. So, okay, so for right, so then now if x minus I plus 1 x I know I could write this loop in a better way, but I'm just too lazy to think about it, and there are not that many numbers. Okay, let's submit this to Q1. Okay. Okay. Oh, how many people have gotten it? 142. Maybe there's a dumber way. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. My explanations are pretty good. Yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.